Okay, so for our molarity review, we want to basically use the formula. We have molarity equals moles divided by liters. Or here's a smaller abbreviated version of it. So you need to fill all this stuff in. So the molar mass of a solution, remember you want to take, we'll do number A, or letter A. And we're going to figure out, first of all, we have to list our elements. And we have to, so NaCl, we want to put the the atomic mass times the number of pieces. So for here, remember there's hidden ones. And you want to take Na, so there's Na is 23, and the molar mass of chlorine is 35 times 1 times 1 equals 23 plus 35. Add those together, it equals 58. Our molar mass would be 58 grams per 1 mole. So the mass of the solute is going to be, if your molarity is 1, you actually first you need to figure out moles of a solute first. So then you're going to take the molarity equal, which is 1, which equals your moles, your moles over your your volume, which is 1. So now you basically have to convert. Remember, you want to take the liters, you have moles. You want to take the liters cancel here. The liters, whatever you do on one side of the equal sign, you have to do on the other side of the equal sign. So now we have moles equals molarity times liters. Our molarity is here. Our liters is here. So 1 times 1 is 1. So 1 mole equals 1.0, 1.0. We multiply those together. That gives us this 1 mole. So our moles of a solute would be 1 mole. And we know from our molar molar mass of a solute, 58 grams equals 1 mole. So it's going to be 58 grams. And let's do another one. So let's do H. Okay, so we're going to do H. And H is going to be, I'm going to pause this for a second. So we have to find out iron and chlorine. We know what chlorine is, that's 35. We got that from the first one. So we need to figure out our molar mass. So we list them, Fe, we have Cl, and then we have atomic mass times the pieces, times. We make our little grid. Yes, might seem a little redundant, but hey, it works for me. So 35. We have 3 pieces. So iron we have to look up. We have to look up on our periodic table. I'm going to pause this for a second while I get the periodic table. So here's our handy dandy periodic table. And our atomic mass is going to be 56. And chlorine over here, that's 35. So we go back to our assignment. So we have 56, and we have 1 piece. Remember, there's a hidden 1 as a subscript. So 56 times 1, that's 56. And 35 times 3, that's 70, 105. All right, we add those 2 together. That gives us 11, there's 6, 161. So we have 161 grams per mole, 161 grams per 1 mole. So now we need to figure out what is the mass of the solute. Well, we can't figure that out until we figure out how many moles we have. So we know that we have molarity, and remember we reworked the formula. So the moles equals M times L. We have M, so here's M and here's L. Let's double check. Yep. Okay, so moles equals M times L. We know that M, big M, is 0.1 times 0.5. We multiply those two together, which equals 0.05 moles. All right, so then we're looking for moles of the solute is here, so that's going to equal 0.05. Now we need to figure out grams. So the way we do that is we take 0.05 moles of FeCl3 over 1, put that in parentheses. We set up another set of parentheses. We take our conversion factor, which is our molar mass. So we want to have 161 grams over 1 mole, where the moles cancel. So then we have 0.05 times 161 grams, which equals 8.05, 8.05 grams of FeCl3. So that's 8.05. So that leaves you with 8 more sets of problems to figure out. And yeah, if you need help, you know where I'm at. Feel free to send me an email. Thank you.